Hello, family. Welcome to another session of Maths Fanatics. So, ladies and gentlemen, we are going to be starting with 10.1.2. There's a video on 10.1.1 and the playlist calculus. It's clearly stated that it's on 10.1.1. Our system glitched due to load shedding when we were still recording. So, if you haven't watched 10.1.1, please just quickly leave this video and watch it, and then you'll come to watch this one later when you have that one, since there are follow-up questions. Okay, so now here they want us to calculate the coordinates of B. Okay, and then we also have A there. Remember they said A and B are the turning points, right? So ladies and gentlemen, I want to give you a hint. Please write it down somewhere on your notes. When you hear the question on turning point, extreme values, stationary points, maximum value, minimum value, smallest value, highest value, please always know that you are going to use the derivative of that function is going to be equals to 0. Ne? The derivative of that function is going to be 0. Okay. Why? Because the gradient of the tangent in the turning point, it's 0. It's 0. If you check here, this line is the tangent there, but it's parallel to the x-axis. And the x-axis has a gradient of 0. So all the turning points, all the minimums, all the maximums, the gradient is 0. So when the question asks you about minima or maxima, you do this. Ne? Perfect. The reason why I'm doing this is because they told me that B is the turning point. So what is my f of x? My f of x is 1x cubed plus 5x squared minus 8x minus 12. Okay, now I need to do the derivative at 0. Ne? The derivative will be equals to, remember it's this times that, so the number in front times the exponent will give me 3x, and then we always subtract 1 from the exponent. Okay, so when I have a square, then 5 times 2 is 10. Then you always subtract 1 there, so you're just left with that. And then this one, there's an invisible 1 there, so 8 times negative 8 times 1 is negative 8. The derivative of x is 1, so basically this will disappear because we're going to have x to the power 1 minus 1, which is x to the power 0, which is 1. And then the derivative of a constant is a term without a variable. So the derivative of a constant is 0. So this part disappears, right? Then this is equals to 0. Perfect. When you're here, you can easily use quadratic formula to get your 2x values. But to save time, I'm going to use trinomial factorization. So 3x, and then we have x there. And then here we're going to have, okay, I'll put positive 4 so that it gives me that. And then here it's plus 2. So 3x plus 2. Sorry, I mean this must be a negative. Minus 2 equals to 0. Or x plus 4 equals to 0. Then this side we have 3x equals to 2, or x equals to negative 4. And then we have x equals to 2 over 3. Awesome. So we got the x value in the turning point, right? 2 of them, negative 4 and 3, and 2 over 3. So one of them will go there, one of them will go there, right? So now, obviously, I see that this one is on the left-hand side, this one is on the right-hand side. The one on the right-hand side is always bigger, right? And the other way to look at it is this. This one must be from there, so it has to be positive because the x values, they are positive. This one must be from there to there, so it will be negative side. So this will be xb, and then that one will be xa. Do you see it? Awesome. So we're going to now do this. Because I have the input on x right? I have an input on point B. I can easily get the output by substituting into the original function. So I'm going to look for f at 2/3, which is, I'm going to substitute there into the original. Don't substitute into the derivative, you substitute into the original. So you have 1, 2/3, x, and then cubed, and then you have plus 5, then you have 2/3 squared, then you have minus 8, then you have 2/3, then you have minus 12. Then what will be our answer? Let's quickly check on our calculator. Okay, so let's put it here so that we can see properly. Awesome. So now I have 1 in bracket 2/3. And then here I have a cubed, so to the power 3. And then I have plus 5. I have 2/3 again there. But now this time I'm going to square it. Then I have minus 8. I have another 2/3. But now I don't do anything. Then I have minus 12, which gives me that value there, which is negative 400/27. Therefore, remember, a coordinate must always be written in point form, right? X first, and then your y value is 400/27. That's how we find the coordinate of B. Then we're done with this question here, right? Awesome. So now we're going to do 10.1.3. Okay, 10.1.3, they want us to find the x coordinate of the point of inflection. Okay, so point of inflection, it's also a special point. We do the second derivative equals to 0. Ne? Turning point, first derivative equals to 0. Point of inflection, second derivative equals to 0. So because I already have the first derivative, I have to derive that again to get the second derivative. Ne? So this times that gives me 6, and then minus 1 there. So I have 6x. And then this times 1 will give me plus 10. Remember, the derivative of x is 1. So it disappears. Also, the derivative of a constant is 0. It disappears. So we have that, right? Then I have 6x equals to negative 10. And then I have divide by 6. I have divide by 6. Then I have x equals to negative 5/3. Okay. That is the first way to get it. Ne? The other way to get it is this. Ne? I'll show you something. X on the first turning point plus x on the second turning point divided by 2 gives you the same x value, like the same x value on the point of inflection. When you add the x value here and the x value here, you divide by 2, it will give you some x value there, which is the midpoint. Ne? Sure. So let's prove if that is true. We're going to just use a calculator to prove it. Let's see. So AC fraction, my first x value on the turning point was, my XA was negative 4. So I have negative 4 plus, then my second x value was 2/3. So 2/3 all over 2. Right. What does it give us? Let's see. It gives us the same x value. Do you see it? Negative 5/3, negative 5/3. So I'm sure now you know how to find the x value on the point of inflection, right? Obviously, if the question was asking for the point of inflection, you would take this x value and substitute there on your x values to get the y value, therefore a point. Okay. So ladies and gentlemen, we're done with this question now. We're left with 10.2. We're going to look at 10.2 just now. Okay. Okay. So here on 10.2, they say we must determine the equation of the tangent G. Okay. Remember, they told us that C is the point where the tangent and the F meet, right? But I can also see that C is what? Is the y-intercept. So C basically is this, right? So on C, my point is 0 and -12. Right. Remember, the constants, right, are always your y-intercept for cubic function, parabola, and a straight line, né? For those three. Perfect. So now, let's see. To get the equation of a tangent, remember it's y equals to mx plus c, where c is the y-intercept, right? So I already know that my y-intercept is -12 in this case. It was already given. Does make sense? Awesome. So now the only trick that I need to know is to get the gradient. It's so easy. The gradient, remember, the derivative is also the gradient, right? So you're always going to take the gradient of the tangent, says the same as the derivative. Sure. So basically m is what? Is 3x squared plus 10x minus 8, right? But what is the x value where they meet? They are meeting at x is 0. Do you see it? So we're going to have 0 there. Squared plus 10, 0 minus 8. So your m is -8. Therefore, g of x is going to be -8x plus what? I mean minus 12. Ne? And then that is the equation of the tangent. Right. And then the other thing that you need to put in your notes is this. Ne? So m, basically m tangent, you're always going to say equals to the derivative of the function, which is also the gradient. Okay. Awesome. So we're done with this question. Now let's do the last question. The last question. Okay. So the last question, they say f prime of x multiplied by g prime of x must be positive. Okay. So here I'm going to use this idea. Ne? Always when you multiply functions, you're just going to do this. Look. So I'm looking for negative multiplied by negative will be positive, because greater than 0 means positive. Does make sense? So this will be my first solution, because here I'm seeing this part says must be, when I multiply them, I must get a positive, right? Or I can have a negative multiply, a positive multiplied by a positive will also be a positive, right? So I cannot have a negative and a positive multiplying together here, because they're going to give me a negative. Sharp. So having this idea now, I'll show you something else that we're going to do. So let me pick a different color. So guys, remember, prime of something means gradient. Ne? So the gradient of that multiplied by the gradient of this. Ne? Sharp. So here we're not talking about actual functions, we're talking about their gradients. Okay, sharp. So now we're going to do this method. This is a straight line. Its gradient is negative. So which means this function is what? It's negative throughout. So negative, 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 and so on, right? You just show with that the gradient is going to be negative, not necessarily the function, but the gradient is negative throughout, right? Now let's choose a different color. Remember, for a curve, if it's going up, the gradient is positive. Then if it's going down, the gradient is negative up until B. Then it's going up, the gradient is positive. So here we're going to put positive, 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 because the gradient is positive. Then positive, 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 positive. Then on the turning point, we start going down. So negative, 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 negative. negative, 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 up until B. We start going up again. So positive, 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 positive. Right. Sharp. Remember we said, okay, so we agree that the X on B separates this, and then also because that's where the signs are changing, you see positive, then negative. So also the X on A is separating, right? Now I'm going to look for portions where the signs are the same. Ne? So for example, from here to there is part of my solution. It's not part of my solution, I mean, because this one is positive and the other one is negative. So this part is out. Ne? Perfect. This part here, from here going there, it's also not part of my solution because this is positive, that is negative. If I multiply them, I'm going to get a negative. I need to get a positive, you see? So my solution will be where? Will be from here to there. Does it make sense? My solution will be from here to there. But now, because both of them are negative, ne? But I have to consider that here they didn't say O equals to 0, right? So this part here must be excluded, this part, because you see these graphs are equals to 0 when we multiply them, right? So which means I'm going to have two intervals then. Eh? The first interval will be from -4 to 0. So this is how we write it. So -4 x, right? Not including -4, then x, right? And then 0, right? Then when I say O is 0, and then you say x, then you say 2/3, which is, so you did the, so remember here it's x equals to 0. So you do them because you have two apartments. This is the first compartment, that is the second. Some people can just do this, ne? This, and then they say x, and then they say, then they show us here that x cannot be equals to 0 because x equals to 0 is found inside. But because here they did not say O equals to 0, you have to show us that x cannot be 0. And then, yeah, that should be it about this question. If you found this video really helpful, please share with family and friends and hit the subscription button. Tango, aluta continua. See you soon.